Welcome to Prince Maths Clinic, the e-learning solution at your pace and time.
We'll be looking at the roots of polynomials. But before we go deep into the root of polynomials, we will first like to know the roots of quadratic equations to begin with. Having said that, we know that the generic form or the general form of a quadratic equation is given by ax squared plus bx plus c equal to 0, where a cannot be 0. A cannot be equal to 0. But my b or c can be 0. But a can never be 0. Having known this, that quadratic equation ax squared plus bx plus c equals to 0, when we say the root, what we mean is that what value of x are we going to put at the left hand side that will make this left hand side equal to 0, which is on the right hand side. That is what we mean by roots. Having gotten that clearly, so what do we need to do? We usually in mathematics represent the root of a quadratic equation by two Greek letters, which is alpha and beta. Therefore, I'm going to say that let alpha and beta be the roots. If alpha and beta is the root, I am going to equate this with something, and watch what I'm going to do. Therefore, I'm going to say ax squared plus bx plus c is equivalent. Now, if you have not seen these three symbols before, it means equivalent. It's equivalent. I will come to this later. So it's equivalent to a into, since we have said alpha and beta are the roots, I'm going to say x minus alpha multiplied by x minus beta. So coming back to this, what's the difference between an equal to, which we use in an equation, and equivalent? For instance, if we have 3x plus 2 equals to 8, in this place, x can only be 2. If you solve this, x can only be 2. To make this equation here equal, this left hand side equal to 8. But when we say equivalent, equivalent is a stronger word in terms of saying that whatever value of x we put here, it will always give us what we have at the right hand side. So, and of course, you know that if I put x here to be 3, or for instance, if I say this is equivalent, and I say x is 3 here, it means this statement is not true, because 3 times 3 is 9, 9 plus 2 is 11, and it's never equivalent to 8. But it is only 2 that we say 3 times 2, 6, plus 2 will give us 8. Now, having known that, let us go back to what we are doing. What I will do next is this. This is equivalent, right? So I'm going to expand what I have here. Remember, equivalent a. So x times x will give me x squared. Then x times beta minus beta will be minus beta. But let me do this first. X times minus alpha will become minus alpha times x. Then of course this is minus beta times x. Then minus alpha times minus beta will give me positive alpha beta. Good. So I can now spread this over everything. But before then, I want to simplify this. So this will be equivalent to a into x squared. Then since x is common between this, I'll say minus, then I'll say alpha plus beta, all have x in common, then plus alpha times beta. Good. So convince yourself that this is same as this. Look at it. Minus alpha x, that is what I have here. Then minus times plus minus beta x. So I want to distribute this over everything now. So this will still be equivalent to ax squared, then minus a, open bracket, alpha plus beta x. Then this times this will be a, then alpha beta. Please ensure that when you write your a, make your a different from alpha so that you can easily identify them. I haven't done this. What it means by equivalent is that what I have here should be the same as what I have here, which we have expanded to this portion. So you can see that ax squared is same as ax squared, so it means that they are coefficients. What is coefficient? Coefficient is simply the constant before our variable. So in this case, our a, b, c are our constants. So in this case, the coefficients of x squared here are the same. Therefore, the coefficient of my b here, this is x. So the coefficient of my b, I can now say therefore my b is everything I have here, which is negative a alpha plus beta times x. Then my c is equivalent to everything I have here, which is a alpha beta. So what can we deduce from this? It means that if I divide both sides, oh sorry, I'm not supposed to write this x here. So it means that if I divide both sides now to get the sum of the roots, alpha plus beta are the sum of the roots. Remember we said alpha and beta are the roots. So if I divide both sides in this equation by negative a, so it means that the sum of the root, which is alpha plus beta, will be negative b over a. Then in this case, the product of the root, which is alpha beta, will be c over a. So we will be using this formula to find the sum and product of roots. And the interesting thing about this is that it tells us a lot, it gives us a lot of information about the relationship between the sum and the product of roots. In the next video, we shall be looking at how to apply this to reinforce the knowledge of the sum and product of roots of not just quadratic equation, then we'll take it further to polynomials as well. So till we meet again, keep practicing maths. Bye for now.